Hi, welcome to this lesson on calculus, applications of the first derivative. Let's have a look at question 6. We're given a rough sketch below and we'll determine any stationary points and intervals of where the function g is increasing or decreasing. Now, if we look closely at the given diagram, we're not given the function g, we're given g prime. G prime is the derivative. So this graph here, this quadratic graph, is the derivative of some function f. Or g rather. So in this case, g is most likely a cubic function because it's 1 degree above the quadratic. Okay, so let's see how we can interpret this. Stationary points. Okay, so stationary points is when your g prime of x is equals to 0. But graphically from our graph, this is g prime. So where is it equals to 0? Well, those are the intercepts, -5 and +1. So therefore, at x equals 1, or x equals -5, those will be stationary points. Okay, so you can see the interpretation is extremely important from looking at this graph. Because if we were looking at, for example, some cubic graph, okay, so stepping outside here, let's see what this looks like. This is g prime, the derivative. Okay, you see the g prime is positive here. The values for g prime are positive when it's less than -5 and greater than 1. So that means that your graph is probably increasing because the derivative is positive. So your graph is most likely increasing up to those points, something like that. And then because it's 0 there, it's a stationary point. So it needs to, can you see all the y values here are negative for g prime. So when your derivative is negative, that's when you have decreasing on your original function g. So it most likely decreases like that, finds a stationary point at 1 here, and then starts to increase again. So you can sort of see again a rough idea of what this cubic looks like from this given information. Okay, so stationary points are going to be here at -5 and +1, because the g prime, the derivative is equal to 0 here. And then for increasing, we said, well, that's when your g prime of x is greater than 0. So this interval here and this interval here, that's when your g prime is greater than 0. Okay, so that is equivalent to x is an element from -infinity all the way up to -5, union, again, from 1 to infinity. And then where's your function decreasing? Well, again, from the given graph, that's when it's the derivative is less than 0. And from that given information, that interval is x is an element from -5 to +1. All right, so this was a very interesting one because we first had to identify that the graph that we were given wasn't the original function g, but rather the derivative of g. So this graph here tells us how the original graph is changing over time. It's increasing from -infinity to -5. Then the rate of change changes here. It becomes a stationary point and then becomes negative. So now the graph is decreasing. The rate of change is negative. Then again, it reaches another turning point, a stationary point rather, and then begins to increase again. All right, so it's very important that when you read a question, you read the context very carefully. We were given the derivative function, not the original function. Okay, so that's how we would do this type of question. I'll see you in the next one.